Hi friends, welcome back to this channel. Today, we're going to be looking at how to implement a queue using a singly linked list data structure. First, we're going to be looking at the theoretical explanation, kind of an overview. Then we're going to proceed to the code implementation. And I've also included unit tests. So let's have a quick review of a queue abstract data type. If you take a look at this diagram, you will discover that we are adding elements from the back of the queue and we are removing elements from the front of the queue. And this is how we expect a queue to behave. Now, if you take a closer look, you will discover that the first element that enters the queue is the first element that will be removed from that queue. Okay, so this is the expected behavior of a queue abstract type. There are several ways to implement a queue abstract type. You can use a singly linked list, as I'm going to be showing you in this video. You can use an array. If you're using a static array, then I would advise you make the size of the static array big enough. Okay, but if you are using a dynamic array, you don't need to bother about the size. You can use a doubly linked list to implement a queue also, and you can also use even a stack, right? So you can use stacks to build to implement a queue abstract type. And in my next video, I'm going to be showing you that. Okay, so I'm going to show you how you can use a stack or using stacks to implement queue abstract type. So please stay tuned for that. So let's assume you have this set of operations that you want to perform, okay, and you actually want to use a single linked list to implement the queue, okay. So the initial state of a singly linked list is that the head and the tail points to null, okay. This is the initial stage of a singly linked list. So now we're going to enqueue 6, okay. So when we enqueue 6, now the tail and the head points to 6 because 6 is the first element in the singly linked list. Okay, so now we're going to enqueue 3. Okay, so we've added 3 to the linked list. Then we're going to enqueue 4. So if you pay a close attention to this pattern, you will discover that we are moving the tail to the new element that we are adding, okay, or that we just added. Okay, so if I enqueue -5 here, you can see that the tail now points to -5. Okay, so we're going to enqueue 17, and we've exhausted the enqueue operations. Okay, so you will discover that the head is static, like we're not moving the head pointer, but we have been moving the tail pointer to the right. Okay, and this is the opposite of the queue. So for the queue, we are only going to be moving the head to the right. Okay, so to dequeue 6, okay, we will have to shift the head pointer from 6 to 3, like this. Okay, so now we've dequeued 6. Okay, and we have to set the the node 6 to null so that it can be picked by the garbage collector if you are using a language like Java. Okay, so just set this to null so that it can be picked by the garbage collector. If you are using a language like C or C++, you have to manually free this space. You have to manually deallocate this this memory location. Okay, but I mean, if just set this to null if you are using Java or JavaScript. Okay, all right, so enough of that, right? Okay, so now to dequeue 3, we have to shift the head pointer from 3 to 4, like this. Okay, so to dequeue 4, we have to shift the head pointer from 4 to 5. Okay, so I believe you get the pattern now. Okay, so we're going to dequeue -5. We're going to dequeue 17. So the tail and the head now points to null. So this is the this is an overview of how you can use a singly linked list to implement a queue abstract data type. All right, so let's take a look at the source code. Okay, by the way, I have this source code already on my GitHub repository. Okay, so you can, I know this link is long, okay, so I'm gonna put it in this video description so that you can just click on it and you're gonna be redirected to my GitHub repository. And also, please start this repository so that it can be noticed by other people. So over here, I have the code implementation of a queue abstract data type implemented using a singly linked list. By the way, the programming language used here is Golang, but I'm going to explain the concept clearly so that you can implement it in any language that you use, because the concept is the same in all languages. I'm going to import the external packages that I need to use in this program. Okay. So the first thing I'm going to do here is to create a queue struct. Okay. A struct can be compared to a class, or uh, a class in Java, or a class in JavaScript ES6. Okay. So it has fields, and the only field here is the list field. Okay, and the list field is of type singly linked list. The first method here is the size method, and that returns the size of the queue. And because we are implementing the queue using a singly linked list, that is going to be the size of the singly linked list. Okay. The next method here is the empty method. Okay, this return a boolean type. So if the linked list is empty, meaning that the size is 0, this is going to return true, otherwise it's going to return false. And take note of the time complexity over here. This operation is performed in a constant time. It is a single operation. Okay. The next method is the pick method. So the pick method, I have explained in the previous video. The pick method allows you to check the element at the front of the queue without removing that element. Okay. So we're going to check if the queue is empty. If the queue is empty, then we're going to return an error saying that the queue is empty. You can't check out the element at the front of an empty queue, right? I mean, that's not rational. Okay. Otherwise, if this is false, then we're going to return the element at the front, okay, of the linked list. Okay. And that is going to be this element over here, and we're going to return that. By the way, if you're wondering what this underscore means, it means that this this method is returning two values. Okay, but we're not using the second one because this used to check if that list is empty or not, but we are already doing that over here, remember. So we don't need that value again, so that is why we set it to underscore. So this is kind of Golang specific, right? So if you are not using a variable in Golang, just set it to underscore. All right, so the next method here is the dequeue method, and this is used to remove the element at the front of the queue. It takes a constant time too. So we're going to check if the queue is empty. If it is empty, we're going to return an error as usual. Otherwise, we're going to return the element at the front of the linked list, which is the head of the linked list. Okay, I'm going to return nil here, meaning that there is no error. The next method is the enqueue method. Okay, and this is used to add elements to the back of the queue. Okay, so it takes in the value you want to add, and it returns a boolean, either the enqueuing was successful or not. So basically we are adding to the singly linked list over here, and we are returning a boolean, true or false. Okay, the next method here is the contains method, and this is used to check if the queue contains an element or not. So we're going to pass in the value that we want to check, okay, and we're going to return a boolean or an error. The first thing to do is to check if the queue is empty. If the queue is empty, just return an error saying that the queue is empty. So otherwise, check if the element is contained in the singly linked list. Okay, so this method is coming from the singly linked list implementation. Okay, and it returns a boolean. So if the element is contained in the list, it returns true. Otherwise, it returns false. Okay, and because there is no error, we're going to return nil here. This is going to be set to nil, meaning that there is no error. Okay, so the last method here is the print queue method. Okay, so this is just there to print out the element in the queue, which is also the element in the linked list. Okay, so you don't need to pay too much attention to this. This is kind of a customized method for me. You don't need to pay too much attention to that. All right, so over here I've written the test cases for all these implementations, so you can go ahead and check it out. So I don't want to bore you with explaining everything, okay, so just go ahead and check it out. So we are writing this test to ensure that the implementation meets our expectation. Okay, all right, so just in case you want to see how this is also done in JavaScript, I have a kind of a lightweight implementation here. It is also in my GitHub repository. You can check it out. Okay, all right, so thanks everyone. Thanks for staying till the end of this video. Please like, subscribe, and you can also share this video if you know you really enjoyed this video. I mean, that keeps me going, that motivates me. Okay, so just hit the like button, subscribe, and once again, thank you. See you in the next video. Bye.